finding those educators. Sorry about my joke about the IDE, by the way.
Hi, thanks for your talk. It was wonderful. So you said you named a number of problems that you have idle specifically, and that you're looking for alternatives. Now, the canonical answer to making Python interactive and accessible these days is the Juniper Notebook. So what's your experience of that, and do you see any ways to make that more accessible for children specifically? Yeah.
So I mean, we could be right now, right? There's a whole bunch of things that are already out there. It's like, well, how can we just take something that exists and make it slightly better? But I think actually we need something that is completely simple, that is designed specifically for education, right? I don't think we should be taking systems and things that exist out there already, which are used, for other purposes, rehash them. I think we need something its main purpose is delivering Python in education. So, there's a whole, like I said, there's a whole views, but that's not really their sole purpose. And I think if you start from that point, help an 8-year-old get started with Python, that there is a simple tool that they're able to use.
Any other questions? Okay. I'm sorry, we only have one mic, so it's going to take a little while to reach all of you.
We're keeping you fit.
I'm not going to run too.
With respect to IDEs for Python in education, we all know that to grasp a full-fledged IDE is a difficult task for beginners. Then what has the educational edition of PyCharm that you said that is applicable to use in education instead or in place of IDLE, for example, that it is the most simple IDE that we have for Python?
Yeah, I mean, it's simple to you. When I've installed it and tried to get started with it, it wasn't simple for me. I found there was a whole bunch of windows I had to get through. You have to create a project and open the project. That's a whole bunch of steps that actually, if I was doing a class full of children, okay, this is the first step. You need to click here and do this. This is the next step you need to do. That's a whole bunch of time wasted when actually what I'm trying to teach the children is computational thinking. The language is kind of second to that. I'm not specifically teaching them Python. We're using Python because it's such a great language, but the goal is not to teach them Python, it's to teach them to think computationally. So I'm losing a whole bunch of time in my lesson. I've only got 50 minutes in my lesson to setting it up and getting them started with. I also have to download it and install it, which in a school system is not as simple. I have to get the network administrator on side, they have to create a package, and they have to apply that to everything. Obviously, I come from Raspberry Pi. I would like something that was lightweight enough to run on Raspberry Pi, and we've had a go with PyCharm Education Edition, but it's not run perfectly. So I think there's just too many opportunities for failure with that for very young children who will click on everything, compress everything. And as a teacher, I need to find time to learn how to use that application when I'm already trying to learn new skills to teach this curriculum. So that's where the problem is.
So, last question. Waiting.
Hi. Thanks for the talk. It's terrific. It's just amazing things.
Thank you.
I have a question about that curriculum. So you mentioned it works in England, Estonia, Australia, New Zealand, Israel. What about other countries? So what is the problem? So if there was some experience, for example, countries from so-called Iron Wall or like from, I don't know, Ukraine or Africa or I don't know, any other countries, if there are some communities or foundations who are trying to reach you and ask how to do it, what were the main problems, how do they struggle with things?
So I really do think at the moment this is a global movement. Just because it's not written in the curriculum, for example, in every country, don't think that it's not happening. We know countries in Africa, like Ghana, we have a whole bunch of schools called academies, which are funded by private sector. They don't have to use this curriculum if they don't want to. right? So we still don't think that we've solved the problem in England. Code clubs are a really great way to start, right? So if you helped run a code club in a particular area, that's where teachers start to see the effect it's having on their children, and then they're more likely to teach it, and then it will kind of snowball from there. It takes governments to change curriculums, unfortunately, but I think teachers can kind of push that a little bit.
Okay. So last question, and then we will thank Carrie-Anne.
That's a great idea to get schoolers to train and learn with Python. As there are also a lot of other programs that have interfaces to Python. Learned Blender, for example, that's there. You can model things, you have physics inside.
Yeah.
You can combine a lot of the lessons in school. Do you use Blender also to show up?
So we have teachers in England who are using Blender, yes, for exactly that, to teach a whole bunch of stuff. I really think computer science and computational thinking is cross-curricular, right? So the stuff we showed you with Minecraft, you can teach maths with it, there's coordinates and so on, you can teach physics as well. And Blender is a really great tool, again, free and open, right? So that's exactly what we want. Yes, it's great.
So thank you, Carrie-Anne. A big round of applause, please, because she really... And yeah, you just go talk to her after the talk. There's a coffee break. Enjoy it. Thank you again.
Hello, hello. Oh, okay. try it a bit.
Hello, hello.
Sí, ¿no?
Hello.
Sí. ¿Qué? No, no te estoy hablando. ¿Qué? Sí, es 10 minutos. Un bravo, un ipipurra.
Ahora sí. Hola. Sí.
Si necesitas cualquier cosa, para que le hagas una señal a él y él es el que controla. Perdona, ¿estás tú de...?
Claro.
Faltan voluntarios. No aparecen en las salas.
Después de la noche de pinchos.
Joder. Estoy, mira, mi botellita de agua. Pues te iré enseñando, no sé. Te iré enseñando el papelillo este de 10 minutos, 5 minutos, tal.
Yo me voy a poner...
Lo que pasa es que te lo sacará un poco de...
45 minutes.
In 30 minutes to leave, 5 for Q&A. It's going to show you 10 minutes. So we have at least...
5 minutes for introduction, 5 minutes. So, 35 minutes for the talk itself, and 10 minutes before that I show you. So, fine. Hi, I'm Alex. Alex.
Alejandro, you can say it's Alex.
Just Alex. Yeah. And your work at Laker? No, that's the reason. You work at... I don't believe it's intelligence here in local Spanish country. So should I just introduce you as Alex? Yeah. It's Alejandro. Alejandro.
That's it. That's work. ¿Funciona? Sí.
everybody. Good morning. I'm Alejandro, DevOps engineer at Intelligence, here to speak about extending Ansible with Python.
Well, good morning, and thanks everybody for attending this talk. As Peter has said, my name is Alejandro Guirao, and I'm not
let me introduce Fabian Kreutz. He's going to give his speech on.
Okay, so I was saying I'm not a top-notch engineer. I'm not a top-notch developer, neither a top-notch system administrator. So that's the reason that my job title is DevOps engineer. And today I'm going to talk about extending and embedding Ansible with Python. Please raise your hands, any one of you who has used Ansible before? Oh. Right. I'll have a brief introduction, like 5 minutes, just talking about what Ansible is for people that are not familiar, and then I'll continue explaining how to do some hacks and how to do some leverages, improvements, and integrations, which is the part of extending and embedding. First, the introduction, the 101 to Ansible. What Ansible is? It's a configuration management tool. You maybe know many of those tools. There's also Puppet, the Chef, SaltStack, CF Engine. Well, the basic idea is to be able to automate the configuration of hosts. And by hosts, I mean virtual machines, bare metal, everything can be managed. And, well, there are many alternatives. And basically, the strong points of Ansible is that it works over SSH out of the box, and it is agentless. That means that you do not have to install anything in the host systems apart from Python 2.x. And another very strong point is that it is quite readable, and it has a smooth learning curve. It's not steep because it's DSL, its language is YAML based, so it's quite readable, and it's easy, very easy to get on and start it. The example of an answer in which there's a central node called the management node of the controller, which could be a laptop server in which you run the Ansible software. Then you will have some inventory files that describe the IPs and DNS names and the groups of the hosts that you are managing. And then there are the hosts, which are remote machines that can be accessed over SSH. And there are a series of playbooks that are like scripts that the Ansible machine executes in each one of the hosts that is managing. So this could be a very basic host file in which we define two groups of servers, one of web, another of DB servers. We can find variables that are common to a group of servers, for example, the username of the DB group, and we can define meta groups that group like this one, which is infrastructure group that joins the web and DB group. There are two ways to use Ansible. Basically, there are ad hoc commands and using playbooks. So ad hoc commands is the easiest way. It's the hello world that everyone does, and they are just throwaway one-time executions in which you use the Ansible command in order to execute a module in a group of hosts. And the syntax is very simple. Just issue Ansible, name of the group as your inventory file, -m, name of the module, and -i, the options. This could be the hello world that everyone has done. We are using the module called ping, that the only thing that does is respond with a pong in the server. So if we issue Ansible all -m ping, and all is a magical group that groups everything in the inventory file, then we would have this response. In each one of the servers, we would have the answer that is pong, and also there's a value that says that that states if anything has changed in the remote host. And the other way to use Ansible is to use the playbooks, a much more structured way to do configuration management. They are basically YAML files that specify and each place a series of tasks that are applied to a group of hosts. And each one of those tasks is an execution of a module with some parameters and a description. This could be one task that is ensuring that the Nginx server is started. There's the description, this is the module name, and those are the parameters saying that the service is Nginx and the state we decide is started. This is an example of configuration management concept. This is that we define the desired states and not the actions to be performed, so that this module is clever enough to know that maybe sometimes it has to start the service, sometimes just make a no-op and go on. This could be a playbook to deploy the Nginx server. In this playbook, we are targeting the group of hosts named web. We define some variables, and this is the list of tasks. As you can see, there are modules to add repositories, apt repositories, modules to install apt package, modules to manage services, modules to create or remove files, removing a symlink, and modules to template out things like Jinja 2 template that are going to template out in the remote host. And also there are handlers that are special kind of tasks that are run once independently of the number of times that they have been notified during the playbook. So this could be the execution of the playbook. We will have an output that sequentially shows the results of the task in each one of the hosts. And finally, there's a nice recap. Just to finish this introduction, the way to manage things is using a kind of encapsulation that is roles. Roles is a little bit more advanced concept in Ansible that just is a group of variables, of tasks, of handlers, files and templates, and maybe even dependencies to other roles. So we have finished our introduction. Now we'll be talking about how to hack Ansible. There are two ways: embedding and extending Ansible. So what do I mean by embedding? I mean calling Ansible modules and playbooks from your Python code. And well, this is basically possible because Ansible is based on Python. It's written in Python, so it has some kind of a Python API. It's not very well documented, but it's quite easy to use. And if you read the source code, you will have the you will see how to use it, although you can just continue and see how we can use it in this presentation. Just before we start, a few disclaimers. This code is valid for Ansible version 1.9, which is the current stable one. Probably in version 2, which is the common one, things are going to change. This API is going to change, and probably even the plugin mechanism is going to change, so this is only valid. I can only guarantee that it's valid for the current stable version. And, well, everything in Ansible is Python 2.x only. It hasn't been ported to 3. And you can find the examples in this GitHub repo. So, that we may want to do, we may want to run an Ansible task. This is the simpler kind of automation. It's just calling a module from your Ansible code. How do we do it? Very simple. Just import some classes, basically the runner and the inventory, from the Ansible library. You will build your inventory, for example, directly in code. We may be just targeting our local host, and then making an instance of runner and calling the run method, just passing the module name, the arguments, the inventory that we created, and the pattern of host that we want to target. And just a little digression. I'm talking about facts. What are the Ansible facts? Ansible facts are information that is retrieved at the beginning of the execution of the playbook in each one of the hosts, and there's a bunch of information available for you to make things in your playbook. So you have the host name, IP addresses, the hardware information, even the installed version of the software. So I'm going to make an example, which is the Flash Factor, in which just a proof of concept of embedding a module. I'm running a program that will create a REST API using the Flask RESTful module that parses URLs in this format, getting a fact that we want to know about the system, and it will run the module setup and then pass the JSON that we have showing the fact in our system. It could be just not very practical, but it could be an idea of how we can retrieve information from a remote server. So if we run it in localhost, I can retrieve the version of the software, the base system that I'm running, the version of the kernel, or it's a bit more complex like the network card information. So sometimes we need something more complex than running a module. We need some kind of orchestration. So we may need to run a playbook in a more structured way. So you have to import a little bit more classes, basically classes for the callbacks and utils. You have to build your inventory. It's similar to the other case. In this case, we're also using host variables because in this example, I'm going to attach some information to the inventory, the list of users and apt package I want to install and create. You have to put some boilerplate code just to set the verbosity of the execution of the playbook, and also to register the typical callbacks for the runner and the playbook. And finally, creating a playbook instance and using the module run, specifying the playbook. In this case, the playbook is example. What I'm going to run. I'm going to run a playbook that install some apt packages and create some users, because it's a typical task when you arrive at a system to begin creating users and installing software packages. So I've just created a proof of concept script in which I get via the interactive console the information of the name of the users and the list of packages, and then I call the Ansible, it's called the installer.yml, and I pass the list of packages and users via inventory variables. So that could be an example of this kind of integration. If I run it, I can create users, and I can install packages. And when I finish, it runs in localhost, and it has changed that it has shown that although the current user Alex is created, it has done anything, but for the new user that I've created, which is called George, it has changed the system, also installing another package. So I have called an Ansible playbook from my Python code. Well, one way to hack Ansible is by embedding. Another way is extending Ansible. And by extending, I mean adding more functionality or customizing its behavior. Basically, it's done by 3 ways: creating modules, creating dynamic inventory scripts, and creating plugins. So let's start with creating an Ansible module. Ansible ships with tons of modules, ranging from creating usernames, managing databases, spinning cloud servers, but sometimes we need something more specific to our business. So we have to create a module. And what is an Ansible module? It's just an executable file that you will find in the some folders in the .library relative to your playbook or in the Ansible library path. And basically it has a JSON interface, so it expects JSON for the input, and also it emits a JSON for the output. So it's language agnostic. You can do in Bash, you can do in every language that you want, but if you are using Python, then it's easier because there are some helper functions that will make it really easier. This could be the example, the structure of a typical module. I've borrowed some parts from the existing modules, and basically it's a file in which you have two strings. We will come later to them, that are the documentation and examples. Then this part of the code is what I call the Pythonic part, in which we do the hard work. We import the libraries in our business logic, and then from that point, this is a template, let's say, in which we define a main module. We do some instantiation of the Ansible module class. We call our Pythonic part from this from this function, and then we emit a different kind of JSON depending on the result. So let's get on more detail. Documentation and examples are two strings variables that are very important because they are used by Mac web docs to generate the HTML of the documentation. And well, some important parts are there's an option part in which we specified the values of the arguments, and it's important to keep it in sync with the real code, which is the argument spec dictionary. You have to specify the requirements if you need some more Python libraries to be installed in the controller, and you have to use the node section if you need that some environment variable, for example, is present at the controller. And in the examples, just put code, please, that is tested and work, especially if you want to submit it to the Ansible repository. In the part that I call the Pythonic part, it's usually a good idea to put pure Python code, import the libraries that you may need for dealing with the problem, but try not to use the Ansible part because it will make your code more robust to changes in the Ansible API. Helper functions, for example, this one coming from the Ansible module, from the Ansible library, that allows you to easily run commands and find executables in the remote machine. And just some tips: try to return a value and a message, and code every information on those values, and don't print to standard output or error because this mechanism won't work. In the main function, you have to create an Ansible module instance, and when you instantiate it, you pass an argument spec dictionary, which defines the module arguments, defining the series of modules that are required, the ones that are optional, the default values, possible choices, aliases, and then there's a section option in which you specify the module exclusion of the parameters, and also if you support check mode. This is the mode in which you do a dry run and you do not mess with the real system. It's just a test. So when you have created that, you magically have a dictionary in which you have the parameters of the invocation of the module. You have just to take those parameters, call the Pythonic part of the module with those parameters, and then pass the results depending on the status and the message. You have to create some kind of JSON. And if you use some helper functions like this one, exit JSON and fail JSON, then your life will be easier because they will manage everything and create a JSON for you. At the end of the file, if you are Pythonistas, that you all are, probably you are now in tears and in pain because this is the Pythonic anti-pattern, the import asterisk. But please resist the temptation to make an explicit import because really it's like define a preprocessor in C, because Ansible will substitute those lines with the code of the helper function. So if you do not put it, it won't find it and you won't have an import. And if you do not put it at the end of the file, it will change the line numbering and debugging will be a hell. So some module creation tips to make a module you will love to use, module that is a very handy tool included, that is the test module script. And if you want to submit it, please follow the module creation checklist that is available online, and it's much more comprehensive. I've created an example which is called the Taiga issue. Taiga is an agile project management system that has a REST API, and there's a library called Python Taiga that allows to manage it and play with it. So I've created a very simple module that is called Taiga issue. This module is just for creating issues in this platform. For example, if we are deploying a system via Ansible and we find some problem during the automation task, we can create an issue so that the team will see it, will have the information, will have the logs, will have everything. So this I have submitted it to Ansible extra module repository, and basically this is the application part. You have to specify the different options that the module supports, and you have to put some. This is what I call the Pythonic part. I import the Python Taiga, and I'll do the issue management here. It should be the pure Python code. And finally, this is the main part in which I specify the restrictions and the parameters. I parse and I call the Pythonic part with the arguments, and depending on the return status, I issue one kind of JSON or the other. And if we see the playbook, we can just use this module to create a Taiga issue in our project. We can manage the description. We can put also Ansible variables like the host name and distribution. We can attach to the issue a file. For example, we can attach the playbook. Then I will pause, and when I continue, it will delete the Taiga issue because the module supports the state present and absent. So this is the test project that I've created with no issues. And then if I run the demo, it calls the Ansible playbook of the playbook that we have seen. First, it has run the creation of the Taiga issue and it has stopped. If I check here, that I can see the issue has some tags. This is my Ansible distribution, and this is the playbook also. So if I resume, it will go and delete it when possible. Okay, it's not there. So create inventory script. There's another way to hack it. If you are managing cloud servers and cloud infrastructure, probably you know about this. Dynamic inventory scripts are a way not to have to deal with a long list of servers that probably are changing, their IPs are changing, you can scale things. So dynamic inventory scripts are a way to deal with that complexity. They are just an executable file that supports those command line switches. Minus list that will return a JSON dictionary with the name of the groups, and each group is a list of hosts, and minus host, in which you specify a host name, and then you get a dictionary of the host variables, JSON. So just for the fun of it, I did an example, which is shelf inventory. If you know shelf files, they are basically a key value store that Python supports natively in the serialization. So in the example, we are just using a shelf file that I've created, and we can open it, groups, and on the host bars of it. I can pass through the demo. Because we are running out of time, I want to run another demo. Plugins are to hack Ansible in very different ways. Basically, the common thing is that they run in the controller node, and there are different kind of plugins. We're going to see some of them. And basically, the way to add it and to add them is just drop them in a folder. And if you want to use another folder, just trick the Ansible config file. So the callback plugin is just a kind of plugins that reacts in the controller to the playbook and runner events. In order to create them, you just have to define a callback module class and then override the method you want to. There's an example of the list of methods available for this class in the repository. So just a brief example, I'm going to create a callback plugin that reacts to the failed event of a module, and then it will call the notify send binary, which will create a pop-up in my system with the name of the module and the result of the module. I'm running this this playbook. We will just output a message. The first task will go okay. The second one will fail. So I'll get a pop-up saying that the second one has failed. It's just an example of things that can be done. You can make Slack notifications. You can make HipChat. Everything you see it useful. You can create connection plugins. Basically, the connection plugins allows the controller to connect to the remote host, Ansible ships with lots of them. But you can create much more. You'll just have to define a connection class and override the basic methods that are just connecting, disconnecting, executing commands, putting, and fetching files, which are basically the things that Ansible is doing in SSH mode. You can create plugins. Lookup plugins allow to expand the functionality by accessing information in external sources from the controller, for example, in databases, in file systems, and the syntax is just calling the lookup function. And also, if you define a lookup, you'll get a with expression that allows you to loop over some results. So you just have to create a lookup module class and basically define an init method and a run method, which will pass the terms, which are the function, the arguments of the lookup, and then return a list of results. Following the example of the shell file, I can define a shell file lookup that will search for a shell file and retrieve a key from that shell file. Basically, I just implemented the run method, and just a demo. In this playbook, I'm opening the book.db and retrieving the current book name, book page, and book author of the book I'm reading now and print them. It's a very good book if you haven't read it. And filter plugins. Filter plugins are Jinja 2 filters. Ansible ships with usual Jinja filters, but you can define some other filters The syntax for using them is very simple. Variable followed by a pipe and the name of the filter. Those are example filters that Ansible comes with them, but you can define many other. It's very simple. Just create a filter module class and filters method that returns a mapping from the name of the filter to the Pythonic function that implements it. For example, we can create a filter to rotate 13 positions. This is the Caesar rotation, and just if we see an example of playbook, we can apply once and then apply twice. And we can see that Caesar becomes PNRFNA and then becomes Caesar. So it's working. Finally, just other plugins, very fast. Action plugins that are plugins that allow separation of actions between the controller and the remote host. For example, when you're templating out a file, there are some actions that need to be performed in the controller and different in the remote, so that you can just implement an action module class with a method run, and when you're doing things in the controller, then you execute this method, runner execute module, to call the real module on the remote host. You can define bars plugins, quite an undocumented part, possibly going to change with Ansible version 2, and it's the way that we can retrieve more information about the host via some external source, like vars and group vars directory. Basically, this is the template that you will find in the repo, and you have to implement the get host vars and get for a new plugin. You can create cache plugins, very modern functionality from Ansible version 1.8, in which we can retrieve the information of hosts that have not been contacted in the current playbook execution. Just using a backend like Redis or Memcached, you can run once, get the facts, and then run without having to retrieve the facts of the rest of the host. You have to tweak your Ansible config file, and basically, if you create a new one, you want to create a new one, you just have to implement this template. And finally, those are the references that I have used. Very good books, not just for developing Ansible, but just for using the first two ones, and some articles talking about that. So that's it. Thank you very much. And now, if you have any question.
Any questions?
Well, thanks for the talk. And my question is, you mentioned that while using Ansible as embedded module, it's very hard to find the documentation of API, or is it very poorly documented? So actually, how do I get this information to use it as embedded module?
Okay. If you want to embed a module, like in the first example that I have done, I had to do some research to go into the source code and see how the Ansible command is using the API and try to mimic it. We are using the same API that the command line version, that is just a Python file, is executing. Also, I have seen some other examples which are here in the reference that are much more pragmatic. So I have been inspired from them. I think that in version 2.0 they are going to document it much better. They know in the Ansible project that there's a lacking of documentation in that part. I don't know if intentionally, but there's lacking of it, and it's changing. So when Ansible 2.0 comes as a stable one, probably it will have changed. It's not going to be, I think, not so simple, but more flexible.
about the way of testing modules, do you need to write a specific language, like or library for testing the code, or are standard tests in Python?
Well, testing things in Ansible is quite a tricky aspect, because even the Ansible code base is not very well covered with tests. If you see the project, there are just like 100 and something assertions on the base code, so they are not very concerned about the testing, and testing a module is even much more difficult. I will test the Pythonic part separately, just this kind of part, which is pure Python. You can use PyTest, you can put the test in another files, but there's no standard way to run programmatically test to a module, and you do not have even to make tests, to put tests in a pull request to get your model accepted. They are not very strict with this part. So I would suggest using testing only that Pythonic part, the business logic of your module, using an external library like PyTest, something like that, putting in a different file and importing the functions and the classes that you're defining.
Yeah, so maybe it's easier using something like Test Kitchen.
Like, sorry?
Like Test Kitchen.
Test Kitchen. Well, with Test Kitchen, you are not using like, I think it's unit testing. It's more like I don't know if it's functional testing or something. Test Kitchen, just to focus, is like, is it a tool developed in Ruby for testing Puppet or exactly?
Actually, you can test also Ansible. But the thing is that you can use your module in a test page and see that it has what you are.
I didn't know that it was possible to use. Okay, thank you. I'll keep an eye on that.
Any more questions? Okay, if there are no more questions, then please thank Alejandro.
Thank you.
I'm Ritu. I'm from India. So basically I wanted to know
please come to the front. There's still space in the front row. There's one space there, one here. And okay, so 1, 2, 3, 4. There's one there. And there's one here, and there's one there, 2 there. Two more seats.
Tomorrow I'm giving a training, just in case.
There's one more, so there's... You can sit here and there's one more seat there. So one more.
Yeah, I think so.
There's place here, I think.
Hello.
Okay, please take your seat and welcome Pablo Endefaque, from Barcelona. He works at Skyscanner and he'll talk to us about decorators.
Yeah, that's it. Yeah, good morning, welcome. How's the hangover? I hope not too hard. As I was, let me introduce myself. My name is Pablo Endefaque. I work for Skyscanner. Do you know it? Do you use it? You should use it. Or even better, you should join it. We do pretty good stuff, and we are hiring, so you know. But I'm not here to speak about myself or my company. I'm here to speak about Decorators Demystified. And what we will try to do is try to understand what the add symbol, what this syntactic sugar does. Okay? And to do that, actually, we're not going to talk about decorators. We're going to talk about namespaces and scopes. Because if we really want to understand decorators, we'll have to understand namespaces and scopes in Python. Because if you understand them, you will really know how a decorator works. How many of you have implemented a decorator? Raise your hand. Whoa, a lot. And do you understand what are you doing when you implement it? Or you just Stack Overflow, copy, paste, rename, replace something, and cross the fingers, and it works. So let's try to understand why it works. So at the end, what we will do is we will implement our own handcrafted decorator. Okay? We will try to understand all the basics behind decorators, and then we will implement our own decorator in a really, really simple process. You will see that at the end it's really easy, really simple to understand. But before proceeding with the cool stuff, let me show you something that we will talk. Okay, in first place, this is a really simple software catch. Okay, I have an ordered dig where I store keys and then I retrieve the keys. Do you know ordered dig? Raise your hand. For the rest of you, ordered dig is a dictionary which also keeps the order in which you inserted the keys inside the dictionary. Why do I use a ordered dig? Because I can limit the size. I want to limit the size. It's really simple catch, but I want to limit the size. So you can see the pop item last equal false here. It means that Python automatically removes the oldest, the first inserted item when the dictionary is full or when the dictionary reaches the size that I want to limit. Okay? Do you understand this catch? Yes? Pretty simple, right? Don't use it. Never use it. Please, never. This is a crappy catch, and it does not do what we would like to do usually. But for the sake of the example, we will use it, okay? But usually, you should use functools.lru catch. Since Python 3.2 or 3.3, I don't remember. But you can find the code to implement it. Actually, I think it's in PyPy, in PyPy for 2.7 and 2.6 also. Use that if you need a software catch, okay? More useful stuff for the talk. Factorial and Fibonacci, do you know them? Do you remember them? Yeah? Implemented in recursive way, so the function calls itself several times. In the case of Factorial, only one recursive call, but in Fibonacci, 2 recursive calls. So you can understand that Fibonacci is way, way more complex. Right? Cool. Is it right? Yes? No? Are we awake? However, there is one thing, or more than one thing. What about this? Did you ever stop to try to figure out how is it possible that you're accessing catch there? You come from maybe Java or .NET. Really? You're kidding? For the 5 of Java or .NET, is it weird to do this? Access maybe here, ooh, where is my mouse? Here. Access maybe here the element declared outside the function? Is it weird or not? For the ones in Python, maybe it's like normal. Yeah, I do it every day and there is no problem. But there is something there that lets you access that name there. Did you ever try to think about it? What about this? How is it possible that the function calls itself? How do you know that you are going to have when you are being created? I'm a function and I'm created and I want to call myself. There is a magic there. Let's see another example, even simpler. We can import path from one module. Or we can import path from another module, and there is no clash there. Well, if you do both in the same place, one overrides the other because they have the same name. But they are declaring different modules. How does it work? What's happening here? Or even, I can have a function with, again, path as one of the arguments. And again, no clash, no problem here. Compiler doesn't, interpreter doesn't complain. It works, right? It's something natural in Python because you use it and it works this way and you program and you see it and you see, yeah, it's the way it works, right? Why? Why is the way it works? Why is it happening? Let me introduce namespaces. Woohoo! Come on. Namespaces. Oops, sorry. That's it. Come on, guys. Thank you. What's a namespace? A namespace is a mapping for names from names to objects. Do you know in Python everything is a pointer? So a name is a pointer. It's a name you are giving to the pointer to an object. And that's why, well, no. Let me explain something else. Some examples of namespaces. The built-in names, functions, exceptions. When you implement something like try except system in out exception, whatever. How is it working? What is the name declared? How is it possible that you are getting that without importing? Because that name is a namespace that you can access always. We will see how this always works, how this access works, okay? But that's the built-ins. There are others. There is the global names in every module, like the catch we saw. Catch is a global name in a module, or this way, because at the end it's only an attribute inside a module. Globals, what we call globals in Python, maybe it's a misleading name because in other languages a global is really a global inside all your execution. But here that's not happening. A global is only a top-level attribute in a module, and you can only access from inside the module. So it's better to say top-level attribute, I think, or more accurate. There are also local names in a function invocation. The catch argument that I showed you. The catch argument of the function is a local name of the function. What's this inside? We will see it. We will see it. There is also the last one, which is maybe the weirdest one, but the thing is when the interpreter runs, it has some top-level names that are accessible for you. Okay, they are, but they are there and are relative to that execution of interpreter. Okay, but we can omit this one. So there is no relation between namespaces. That's why we can have path in one mode, placing the pointer to the object. You are assigning a new object to that name, right? Another thing, namespaces are created and deleted at different moments and have different lifetimes. Let's see more examples. For instance, a built-in namespace is created when the Python interpreter starts and is never deleted until you close the interpreter, of course. Right? What about the module global namespace? It's created when you import. No Wi-Fi, sorry. It's created this way. You are paying more attention. As I was saying, the top-level attributes of a module is created for first time, the namespace, when you import the module for first time also. And then it's there because Python reuses it. If you import the same module from different places in your code, in your application, it's only, let's say that the file is once, and Python stores and keeps it inside the memory. So the namespace is created there the first time, and that's it. Unless you do something like reload. Do you know reload? Reload forces Python to re-import something. And that's the way to destroy the namespace and create it again. That's the only way you have to do it. Otherwise, the namespace will remain there together with the import. However, function local namespace is created every time you call the function. Actually, it's there, but it's filled every time you call the function. And why is there? What does it mean that it's filled? Well, it's because the scopes. A scope is a textual region of a program where namespace is directly accessible. Do you get it? So actually it's the scope which tells you that when you are in a function you can access the global namespace of the module where the function is occurring. That's the scope of the function. And the scope is determined statically. It means that the first time that Python interprets that function, takes the code you wrote and interprets it, Python figures out what are the accessible namespaces. What is the scope of the function? And at that moment, only at that moment is when Python computes all accessible from inside. If you have nested functions, you declare a function inside another function, inside another function, inside a module, then you have different namespaces and all of them are accessible. They are used dynamically, however, depending on where you are or what you are executing at that. You have a different scope. A different scope is applied. So a different set of namespaces are accessible at every moment. Yeah, that's obvious. At the end, it's obvious, right? This is how it works. You call a function, then you have access to the locals plus all the globals. When you go out of the function, you don't have access to the locals of the function anymore. That's the scope. There are at least 3 nested scopes whose namespace is directly accessible. Let's see them. Innermost scope, local names. As I said, when you are inside a function, access inside the function. Then you have functions. And closing when declaring. Remember, declaring, not calling. If you call a function and that function calls another function, you cannot access the locals of the calling functions. That's obvious. You only access what you declare. Okay, so this only works for nested functions. Do you remember how we implement a decorator with a nested function, right? That's why I'm explaining this. After the function and all the functions, what we have is the current module global names. Current module is the module where the function is declared, not the module from where you are calling. Okay, this is really important. A function only accesses the wrongly called globals inside the module where the function is declared. Right? Everything clear so far? Yeah? Yeah? Cool. So names are searched in nested scopes from inside out, from the innermost to the outermost. In the example of the function with an argument called path, when inside the function you try to retrieve path, you get that local name. But if in the same module you have another function which does not have an argument called path, then Python will look in the outer namespaces. And if you were importing os.path, then you would get that path. Or it would fail. If Python goes from the innermost to the outermost namespace, trying to get the name and it doesn't find the name, then it's when you get an attribute error. Right? From one to the other. Remember this also. The access is read-only for the outer namespaces. Right? You can only change the names in your local namespace except the globals if you declare them as global. Let's see a bit of code. Yeah. In green, we have the innermost scope with the current local names. All the names declared there are the names that you can access when you are inside the function as locals. So you can modify them. Then you have the globals, which is the next namespace. And then you have the built-ins. What happens with the names here? You cannot access them from this module, okay? This is a module, this is a file. You cannot access the stuff in your command line or in any other file, right? So you could see it as a kind of tree. That's the uppermost namespace. And then in the leaves, you have the locals namespaces for every function. Is it clear? Any questions so far? Nope. Cool. Let's take this example. Let's spend 1 minute trying to understand what it does. I have a function which does something, forget this something, and returns an attribute. What's this attribute? Actually, this attribute is another function, which I create here. This is a nested function declaration. Okay, so I return the function. What does this function? It does a power, right? With x and y. Where is y? Yeah, we will see it with more detail. How it works. If I call it and I get the resulting function, I can call afterwards a function providing x as 3. You see how it works? Does it have sense? So where is okay, we have in green again the innermost scope. In red, we have an intent. The enclosing function. And in blue, we have the globals. And in yellow, we would have here also the built-ins. Okay, so where is this namespace? What happened with it? We have y there declared, right? Y is declared here in this namespace with a given value. 4 in the example. So the thing is that we have a closure. This is called closure. Did you know closures? Raise your hand. Come on, what I'm explaining them. Correct me please if I'm wrong. So you can see the closure here. This is the enclosing function namespace, but only a small portion of the enclosing function namespace. Why? Because as I said, when you declare the function and Python interprets it, Python computes the scope of the function, and Python determines that the local, the innermost function will access something from the intermediate namespace. And as you will need that thing accessible always, Python creates this closure. A kind of temporal namespace where that name is stored. And that name, y, letter y, pointing to an integer with value 4, is stored there. And it remains there while you are using the function here. So y rise to 4 is a function here, a valid function. We have that closure there stored. And as you can see, actually the closure is a hidden attribute inside the own function. We have also the globals. There is another funny thing in the example. And it's the fact that, as I said, I declare x here, I also have a different x outside. And there is no problem. I'm not replacing one with the other. And how we have in the globals the x. Everything clear? So, in better words, a closure is a reference to each of the non-local variables of the function. And again, the same colors. This is the enclosing, this is the enclosing function scope, the closure. And so far, well, decorators, come on, what's this? I'm fooling you, no, I'm sorry. We will do a decorator, I promise you. We will manually apply a decorator. Let's go back. Remember factorial and Fibonacci. Factorial is pretty fast, right? For 35, it takes 0.00007. That's fast. However, check Fibonacci for 35. Come on, it's almost 7 seconds. 1,000 times slower. Amazing, right? Such a small difference in the implementation. This is the recursive calls graph for Fibonacci of 5. And check the number of calls that we are doing. It's amazing. Imagine for 35. I will need the whole walls of the whole room. So, do you remember we have a cache? Yeah? Do you know what's memoization? Let's apply it. No? Do you know what's memoization? Raise your hand. Cool. Memoization is to store the result of a call to a function with the arguments. This way, you can retrieve the same result if you know that stored result, instead of calling the function and spending all the function. That's memoization. So it works. changes are, if I find my mouse, the changes are here. First thing, if it's not the base case, I check inside the catch. If I have the value stored, I use it. Otherwise, I do the recursive call, and then I store the value, and return it. So check now. It's as fast as factorial. That's a 1,000 times improvement. That's amazing, right? We can compute even Fibonacci of 100, and it takes also nothing, almost nothing. However, don't repeat yourself. Come on, what if we want to apply for 10? That's ugly. Come on, we had the function working fine, and now we change its implementation for catching. Do we need two different functions? One if I want catch, one if I don't want? No. No. We will do a magic trick. Pay attention. Yeah, I'm a magician. I forgot to mention in the introduction. I'm sorry. This is the trick. The function remains unchanged, completely unchanged. Do you see it? I create my function. I store an alternative name to retrieve my function, because at the end a function is an object also. So I have the function object somewhere in Python memory, a pointer called Fibonacci. And I take another pointer called real Fibonacci. And then I change Fibonacci. And this is the question. This is the trick. Which function is called here? I'm fooling the Fibonacci function. The own function believes that it's calling itself, and it's false. It's not happening anymore. Let's say it with the colors. And just in case, let's repeat the trick in a slow motion. First thing, I create the function. This is what happened. I have a global name called Fibonacci, which points to an object, function object, which has this code. Then I create a real Fibonacci name, or real fib, which points to the same object. It's just a pointer. It's just an alternative name to access the same object. And then here comes the trick. Check the two colors, the green and the red one, okay? Now I create another Fibonacci. What happens when I create a new function called Fibonacci? I'm replacing the name in the globals, that's why I have it in green. Okay, the ID. And now I have two function objects. The second one calls the alternative name. And we swap them. That's it. And that's part of the trick, that is that the original function does not know it. Yeah. Hacker and magician, don't forget it. But let's make it even more reusable. Even more. Let's make it to work with any function, kind of any. This is a star because it will work only for functions receiving one argument. Okay, that's the any. But this is a trick to make it work for any other function. And we create a function generator. Again, we saw that with the powers. We do a similar trick. We create a function which creates a nested function and returns that function to let you use it. Why? Because we have to provide the function to memorize, the function to remember, to catch the calls and reuse the result. Right? Because here the only thing that we do is we call the catch with input argument. In case we don't retrieve the value, we call the function to memorize, we store the value, and we return the value. Okay? Check only the code of the nested function. And it works. Look how it works. Do you get it? Clear? Yeah? No? Cool. And it works for Fibonacci, and it works for factorial, right? $250, come on, 250. Without memorization, it would take like all the conference. And finally, at long last, decorators. Woohoo! Let's say decorators. Wait. We spoke about the @ symbol. Where is the @ symbol? Pay attention. It's here. We have it. We have it. You see it? That's all the thing the @ symbol does. Compare both codes. It's exactly the same. So you can use decorators manually, as I'm doing here, and the @ symbol is so stupid. It does nothing. Come on. Thanks for coming, and in case you have questions, the slides are there in the speaker deck, and I guess I will give also to the organization or whatever. Let the organization for yesterday's party. It was great. And what? You made it today. Thank you. Thank you. Hope you enjoyed. Tomorrow I'm giving a training. We will see this. Well, you will do it yourself. You will experience it yourself on your own, and later we will see different types of decorators. We saw a really simple decorator. We'll see how to implement decorators that you can customize its behavior, decorators which store a status, and so on. Okay, tomorrow at 11. So if you want, you are free to come. Questions, comments?
Does anybody have questions? Yeah.
Really? No questions? You need a decorator, that's why you don't have questions, right?
Yeah, hi, I have a question. Thanks for talk, first of all. So you showed how you can basically replace names in namespaces and so on, and you showed the slide, what a good hacker I am. I would just like to have a comment from you about using this technique in production code.
But this technique is what you do every time you use a decorator.
Not about decorators, about changing the names, replacing names, like the first couple slides you showed about Fibonacci, replacing them with real Fibonacci, and redefining the name. Yeah.
But no, seriously, this is what happens when you use a decorator. The decorator takes your function, wraps it, how we saw it, and it works because the function still believes that it's calling it. It's called recursively. Yeah.
Okay.
So it's really happening every time you use a decorator. So every time you're using Flask and you want to add a URL, you are doing this trick.
Yeah. Okay. Maybe my question was a bit confused.
So yeah, it could look like a hack, but that's a decorator. You are taking the function, replacing it, or wrapping it with something. You could even implement a decorator which does not call the real function. That would be maybe hacker.
Okay. Yeah, my question was not about using decorators in productions code, but was
doing
about,
magic tricks.
yeah, exactly.
Don't do them, guys.
Any other questions?
No? Cool. Oh.
Thank you for the talk. Will you talk about decorators parameters on your training?
Yeah, we will see. We will see. This was the simplest decorator ever. More advanced decorators.
Okay.
Yeah, different types of decorators. We will experience this ourselves. So the first part of the training is doing kind of this yourself, and the second part is doing more decorators. Different types of decorators implemented to maybe keep a state inside the decorator or customize the way it behaves. For instance, this decorator here is catching. Why not be able to customize the size of the catch and the time to live? Yeah. We will learn how to do that.
Okay, thanks.
Anything else? Thank you very much. Oh.
One more. While I run, will you cover class decorators on the tutorial?
What?
Will you cover class in the tutorial?
Yeah, I don't think we will have time, but you should use meta classes. I like more meta classes instead of decorating classes, personally. But we will see how to implement decorators using classes. That's what we will see. But we won't see, I don't think we will have time to see how to decorate classes.
So I have a question about using multiple decorators on the same function. Like,
that's dangerous.
How do you see the trade-offs between the complexity of having, like, you know,
that's something that today I didn't mention it, but most probably in the course I will highlight for sure. But the thing is, if you have 4 decorators in a function, it means that the first decorator calls to the next decorator, which calls the next decorator, which calls the next decorator, which at the end calls your function. So that's expensive. So don't do it that, for instance, in your superficie you are doing 4 calls for the same, and sometimes you don't really need them. So take care with that. It's maybe the dangerous part of the decorators, that it's so decorator with the add that you forget that actually you have a function. Usually you do something there, like catching or like logging or whatever you're doing, and that takes time. At the end you have to call one to the other, to the other, to the other, plus all the execution code of each of the functions, which are the decorators. So it's dangerous.
And do you have any tips on, for example, if you have like legacy code that uses multiple decorators on a function, how to refactor it to make it faster?
Maybe if you always use 3 decorators together, maybe it has sense to have only one. Mm-hmm. The end is, maybe it's not about decorators, but it's maybe about modularity. And
all right, thank you.
If you always see it as if lots of things that you do with decorators could be replaced with calling something at the beginning of your function. Lots of times could be replaced by the same. So if you are always doing the three first lines of your functions are the same calls to all logging and whatever, maybe you could have single handler for everything together. Maybe you could have a single decorator for doing all the stuff together if you always do it together.
Hey, does anybody else have a question? Right, thank you, Pablo.
Thanks for coming. I will take a picture if you don't mind. Sit down, sit down. I will take a picture. Come on. Hey, hello. Sorry. Enjoy.
And in 7 minutes, we'll have a talk about testing with verified fakes.
See? I'm sorry for the introduction. No problem. I know it's difficult.
For safety reasons, everybody has to have an actual seat to sit in. So, fill the available seats. Yeah, it's full. Does anybody have an empty seat next to them? No, so I'm sorry. I'm sorry, the room was full, so one seat.
There's 2 seats. There's a seat. Oh no.
Hey, so please welcome the real Richard Wall talking about verified fakes.
Can everyone hear me at the back? Good. Yeah, welcome everyone. Thank you for coming. It's nice to see a full house. I'm Richard Wall, a senior developer with Cluster HQ. We're hiring. So come and see us at the booth. I'm going to talk to you today about a technique we use at work for testing our software, a piece of software that I work on called Flocker. In particular, a technique that we use for ensuring that the APIs that we write and the implementations of those APIs are easily testable, and a technique we use to ensure that all of the implementations of the API, the real implementations and the fake implementation, are in sync and that they behave the same. So, I'm going to start with an introduction. The talk is going to comprise a quick problems that we're trying to solve using these verified fakes. Hopefully, an in-depth discussion of the solution that we've come up with, and then I hope that I'll have some time at the end for questions. But if anyone has a burning question, then just put your hand up while I'm talking, and it'll be nice for me because it'll interrupt. I won't have to be speaking all the time. So, first of all, let's talk about there are a number of problems with testing APIs using unverified fakes or sort of ad hoc mocks or stubs in your tests, and these aren't things that these aren't ideas of mine. These have been discussed at previous icons, for example, by a couple of guys called Augie, I think you pronounce it Augie Fackler and Nathaniel Minister, and they gave a great talk on entitled "Stop Mocking and Start Testing." Well, I'm reading here from some sort of a transcript written by Ned Batchelder. Everyone at Google, where they worked, made their own mock objects. We had n different implementations of the mock, and when the real code changed, you have to find all of those mocks and update them all. And this is a problem that I've seen in Twisted, for example. Oops, I'm not used to it. So I've got quite an interest in the Twisted project. I did some work on the Twisted Names module last year. And so I wondered if this proliferation of unverified mock objects affects Twisted. And it does, because Twisted is about 12 or more years old. And so I grepped for for fake classes across the Twisted code base, and there are at least 7 implementations of the Twisted base protocol, and 6 fake reactors. And the one I'm probably most guilty of or responsible for is the 5 copies of the fake resolver in the Twisted names package. I'm not sure, they may not all be, there may be good reasons for some of this duplication, but I'm sure that some of these could be, are examples of fakes that could be replaced with a single verified fake, which could be used throughout the code base. So that's Twisted, and it's guilty of having these unverified fakes. The next problem with unverified fakes and mocks is that they don't, it's easy to write some ad hoc class which behaves just about the same as the API that you're trying to test. But the trouble is that they're often inaccurate from the very start, and then they grow more inaccurate as the actual real API develops. And so I was looking, while writing this talk frantically over the last couple of days, for an example of this, and someone mentioned to me at the stand a library which I'm quite interested in called Nova Docker, which is a driver for OpenStack Nova, which allows you to create Nova instances as Docker containers. And so I wondered, how do they test that the Nova driver, that the Docker driver that they've written behaves properly with a real Docker daemon, which would be slow and expensive to run, versus an in-memory version of the Docker client. And I found that they have actually implemented a fake Docker client, and it suffers from these problems that I've just described, in that the fake has got out of sync with the real Docker client. It may always have been out of sync. It may never have, because they don't run the tests against both the fake and the real client. They may never links track base classes that are available in Python now. But I've never used those, so I've gone with what I'm familiar with. So we start with a Zope interface called iDocker client, and we inherit from Zope's interface base class. And we define, for each of the API methods described, in this case in the docs, we create not a method of this, but a function. There's no self in Zope interface methods. And I decided to just start with the bare minimum of the create container method. And by bare minimum, I mean I haven't added all of the arguments and all of the optional arguments yet. I'm just going to do just what's necessary for me to be able to use this fake and the real client together. So next thing I do is create a test to verify that the implementations of that interface actually adhere to it. And it's very easy. Zope interface provides us with tools to help do that. We have a test method called test interface, and we use the verify object function, which checks that the instance that you pass to it provides all of the methods that are defined in the interface. It doesn't go so far as checking that the arguments are all the same, but that's something which it would be nice to have, and I've often thought it might be something that I'd quite like to write. So then with that test in place, notice that the test is defined in a mix-in class. We're not actually defining a test case here. I'll show you how this works in a moment. But with that test written, we can run the tests against the real and the fake Docker client, and having decorated the classes, the Docker Pi client class and our fake client class with the Zope interface implements decorator, we can see that both implementations now pass the test. And I'll show, again, I just want to show you some results before I delve into the actual details of how this works. So the structure, in order to get this result, I'm running trial, which is a twisted unit test harness, against tests.integration test, real Docker client tests, and I'm also running the tests, the unit tests, tests.test fake Docker client tests. So we have those two, we have the integration tests, the slower tests which exercise the real Docker daemon in a separate module from the fake, the unit tests which operate on a fake in-memory implementation of the interface. And that's a nice way to, that's the way we organize our tests at work, but maybe we wouldn't, maybe we would organize it a little bit differently. I was making use of some existing integration test modules and existing test modules in Docker Pi, but it's nice to keep the two sets of tests separate. And the other thing that we do is we have the we organize the code in such a way that the tests, the test mixin, which we saw earlier, and the fake implementation are put in a public module. They are, which means that they're not hidden. They can be imported by any libraries that consume this package, and it means that we can use the tools we've created, and other libraries can use those tools too to verify, to use our fake and to verify that their software works with both the fake implementation and the real implementation. I've already said that we have a tests mix-in, which means that the tests are all defined in one class, but that class isn't the test case that gets discovered by the test runner. The way the test runner discovers the tests, or the way the actual test cases are produced, are by way of a test case factory function, which I'll describe. So what this does is the function. Can everyone see the code on that screen? Anyone can't see it? I can zoom in. So this is a function which takes a Docker client factory. And a Docker client factory is a function, it could be a function, or it could just be a class, which, when instantiated, provides an implementation of the interface under test. Then we define a nested class called tests, where we mix in our set of common tests with the unit test case base class, and we define a setup method, which, because this is in a closure, in a nested class, will set up the Docker client factory, called the Docker client factory that was passed in when we call this factory, this test factory function. And then it returns this test case class, which has been built dynamically. And then, to put it all together, we can use that function to generate dynamically a base class for our actual tests. So here we see how we are going to dynamically generate the tests against the real Docker client by passing in, as the Docker client factory, the real Docker client class curried with the certain required parameters. In this case, the version equals auto, which allows these tests to run against any version of the Docker daemon. That may not be quite the right thing to do, but it got me far enough to give the talk. And then we have a similar case for the testing of the fakes. We pass in this time the fake Docker client, and again we're inheriting from the class which has been produced by this factory function. And it's worth noting also that this dynamically this test class gives us a place to document the purpose of this set of tests. And And with that in place, we can start now fleshing out the interface. So so far, all we've got is a test for the interface, a ZOP interface test, which ensures that all the methods are in place and that the methods have the right number of arguments. What we now need to do is start adding methods to the interface. So you can start anywhere, really. I'll describe in a minute some of the problems with this that you encountered when doing this, but I've chosen to start with a test for the DockerPy containers method. So we can start at the very beginning by making sure that when we call containers on the fake or the real client, we get back, and without having created any containers, we get back an empty list. And then we can, well, this isn't quite how I started. This is actually the latest version of the containers implementation in the fake. Then we can go to our fake and we can do just enough to make the test pass. And here you can see we've got an in-memory list or dictionary of container dictionaries, and we're iterating over it and returning just the ID of each container. Which again, this is a starting point. It's quite a long way from being complete, but this is probably enough for me to make use of this fake and library as it is. And so with that in place, we now see that the results of the tests are slightly longer, and we now have both the test passing against the real and the fake, and in both cases the empty list of containers test passes. So then we continue the process, and we write a test, we write the code for that test, and make sure it passes, and we refactor as we go along, because you'll often find that you're creating containers in the same way, with the same image and with the same parameters, and you're wanting to clean up after yourself, destroy containers after the test is completed. And as you write more and more, as you implement more and more of the interface in your fake client, you'll find that you can refactor the tests. And eventually, you get something like this. This is as far as I've got so far with this fake Docker client implementation. Implementations of the listing of containers, the inspection of containers that have been created, the creation of containers, and the removal of containers. So it's quite useful as it stands. We could probably make use of this at work. So I've hinted at some complications while I've been writing this, and the first complication. This has gone a bit wonky, but the first complication is that when you're trying to write tests which only exercise the public APIs, and so you're trying to, in creating a container, you need to create the container and then ensure that that container is listed, or you want to clean up after. No, I'm getting ahead of myself. You want to test that all the containers that are available are listed, but in order to test that, you need to create some containers. So you can't quite implement it method by method. You have to do the practical thing and implement chunks of this functionality together. Another problem I encountered, and which we always encounter when we're doing this sort of stuff, is that you want to start from the very start. If you're running the tests against a real Docker client, you need a way of cleaning up the containers that you've created after the tests have completed. And so to do that, and if your aim is to only use the public APIs, you have to implement a remove container method. But you can't test the remove container method until you've got a way of listing and creating containers. So again, you have to be practical about this and implement the features in sensible chunks. And this is what we try at work to only test the public APIs. It's tempting when you're trying to overcome the problems I've just described. The temptation is to test the sort of implementation details. You might have private helper methods inside your implementation, and you might start trying to write tests for those, but usually it's not worth it, and it's usually just sticking to the testing only the public parts of the interface, the parts of the class which have been defined in our ZOP interface. So, what's the time? That's all. That's as far as I'm going to go with showing you the implementation I've done of this fake Docker client. But I wanted to briefly describe some other examples of this. Maybe not all of them, but some of them are not quite the same as what I've described. The first one is the one that I've most recently worked on at work, where we were tasked with creating a system for our software which allows us to attach, to create and attach and destroy cloud block devices such as AWS EBS volumes and OpenStack Cinder volumes. But we don't want to have to run our tests against AWS, although we do, and we don't want to have to run our tests against OpenStack, but we do have to do it. They're very slow tests to run. What we really want to do is run our tests for this iBlock-based device API against a fake, a sort of simulation of those two cloud block devices. So you can have a look at the code in GitHub here. I'll post all of these slides after the talk. You can have a look at the code and you'll see that we've implemented a loop-back simulation of these block devices. So we've got an implementation of iBlock device which creates loop-back file systems and attaches them to one or more to one process and detaches them and attaches them to another process. And by doing that, we have a way of running our tests for this API much faster than we would if we had to run them against the real Amazon and Open Rackspace, for example, systems. Another example which I am interested in but I haven't yet tried, and developed by amongst others some of the Twisted developers, Glyph from Twisted Matrix. This is a system which allows you to create a fake version of the OpenStack REST APIs. And this is something we definitely like to use at work. The trouble is it doesn't yet implement the Cinder APIs. But that's again, it's something which I'd like to try and do. And what this is a web service which can be primed with both successful and error cases. And it's a web service which you can make REST API requests to, and it tracks the state of as the requests come in. So you can say create a Nova instance, and then you can ask that fake API for a list of the Nova instances, and it'll return you the fake that you've just created, the details of the fake you've just created. And it even, I think, simulates the Keystone authentication for OpenStack as well, which will be really useful. Another one from work, my colleague Itamar develops a library called Elliot, which is what we call a structured logging library. And from the start, he's built into it various features which make it easy for us to test the code that uses Elliot. So he's implemented a memory logger and he has done it the way I've described. He's got an interface called iLogger and a memory logger which implements that interface. And he's gone further than that. He's actually, in the public Elliot package, he provides tools for testing that your code logs the correct messages and logs the correct errors. So that's a really good example of this sort of technique. And finally, I thought worth mentioning is a recent blog post by Glyph about going even further and writing your fakes in such a way that you don't pollute the fake with attributes that aren't actually present in the real implementation. And he's got a really neat way of achieving that separation, which again I haven't done that with my code for this talk, but that's the next thing I'm intending to do. So I think we're about out of time. quickly to summarize, we've seen some of the problems with unverified fakes and mocks. We've looked at some examples of those problems. We've quickly I've briefly shown how we might go about writing a verified fake from scratch. And we've seen some examples of other Python examples of this technique. And that's really it's only a half an hour talk, so that's all I've got to say. I think I'll leave it there. Thank you for your attention.
Right, officially we don't have any time for Q&A, so you're free to go to lunch, but if you'd like to stay and ask questions, then you're free to do that. And does anybody have questions?
Yes. Can you hear me okay?
I can't hear you
Can't
yet.
hear me at all. All right,
Should
I'll
we wait
speak up a
till
little
the,
bit. Or wait a moment, yeah. Just in person.
Maybe.
I'm not sure if it's.
Actually, let's if we can stay. Can we stay in the room? Oh, okay. Well, yeah. Okay. We'll leave.